Okay, so what this one will do, and I think I'll illustrate with the same example. It's a very, very small change to our original method. So here is the intuition. Okay, so here we have a 2x2 system, which I copy pasted from Jacobi. We have the same two equations. Okay, we do the same thing. We solve for x1, x2. Nothing changes here. What changes is how we do the iterations. Okay, so we initial guess. So what is done here is x1 uses x2 0, but now we have an update. We have an improved value for x1. So why discard it? Why not use it immediately as we find it? So what we do here is we just change this from this to 1. That's it. That's the only difference. A minor difference, right? Now, if you have 3 variables, obviously you'll keep updating it. So that's the only difference with Jacobi method. Okay. So the question is, how good is this? Will it give us solutions faster? We have to wait a bit. We'll use this to solve for 3 iterations by hand because we want to check our calculations, and then we'll write code, and that will actually illustrate if this fast any better than. So it's the same problem. Let's take the same. Okay, so it's the same problem. Okay, initial guesses, solve up to 3 iterations. This is exactly what we want. The change being is these iterations won't be like the way they're shown here, right? We have to change them. Let's work this out. Okay, so for x1, we have 7 minus 0 minus 0 divided by 2. Nothing to be done there, 3.5. Okay, same as Jacobi. Next one, however, we do this. We have minus 2. Next, we have x1 minus x1. But now we do have an improved estimate for x1. It's 3.5. 3.5 minus x3. x3 is the same old value, 0. So this divided by minus 3. So I might want you to note that this 3.5 comes from here. And then we have 3 minus twice x1, but we have an improved value for x1. It's 3.5 minus 2 times x2. We also have an improved value for x2. I didn't write it down. It's 1.8333. So 1.8333. Okay, so note that this is the improved, same as the one showed in the same color. And then this too, sorry, this, my bad, the 1.833, this 1.3 was put here. So this comes out to be equals 7.6667. Okay, so there we have a new guess, and that will inform our next iteration. Okay, so I'll write it for one more iteration, and then I'll leave it to you to do iteration 3. Okay, let's take this along. Copy. Okay, my starting point for iteration 2 is going to be x11 is 3.5, x21 is 1.8333, and x3 is 7.6667. So my new x1 is 7 minus x2, which is 1.8333, minus x3, which is 7.6667, divided by 2. That comes out to be minus 1.25. my new x2 is going to be using this formula. So it's -2 minus x1. I'll use this new value, minus 1.25, minus x3, the same old value, 7.6667 divided by -3. And then x3, oh, sorry, this I need to compute. It comes out to be 2.8056. And then x3 is 3 minus twice. Use the improved value, minus 1.25, minus the improved value for x2, which is 2.8056. Divided by -1. Okay, so this 1.25 went here and went here. And then this 2.8056 went here.
By the way, what is this called?
It's called Jacobi, sorry, Gauss-Siedel.
Oh, okay. So this is
0.01111. Okay, that's iteration 2. I would write the iteration. Iteration 3. I would like you to work this out yourself. The answer I got was 2.0416, 1.3842, 3.8516. Okay, I'm a bit rushed because I won't try to finish this today. 2, 3, x1, 3.5, 2.0416. 5, 6. Okay. Okay. So that's 3 iterations. And right now, if you look at the iterations, 3 iterations, and look at the 3 iterations for Gauss-Siedel, it's very difficult to see which of them will do better. This one seems to be a little closer to 1, 2, 3, but there's no guarantee. That one was just fluctuating widely. It was going minus, plus, minus. But okay, so let's write code. Okay, and for this one, I think I can modify the code from Jacobi instead of trying to write new code. So let's just take this. And I'll call that main Gauss-Siedel.m. We'll take the function, make a new file, save this as Gauss-Siedel. Okay, and then I need to go here and call this. So instead of calling this, we obviously want to call Gauss-Siedel. Okay, let's see if this. So I've just changed names, and there your main. Okay, this is a problem which I faced so many times now. Just quit in Windows. It doesn't happen on Mac. It happens on Windows. I need to reopen this file. That's what it is. It just forgets it's in the same path. Okay, so now let's run this. Change directory. And what it gave me is essentially a solution for Gauss-Jacobi method. But I need to make the change, right? That's a small change. It's basically what I need to do here is, if you look at this, the code right here, it's using the old values for x. They're updated every time. So the change I think I need to make is just make this x new. So it'll refine it. And x new is actually defined. It's already been initialized. Let's see. No, I think I need to do this. X new equals x0. Okay. Let's go here. Okay, so here is the solution after 3 iterations. Here's the final solution, which is good, spot on 1, 2, 3. It only took 17 iterations, which is nice. From 583 went down to 17. And you can check the answers here for the first 3 iterations with what I have here. It actually lines up pretty well with what I wrote down. So one small change to, well, the 2 changes to the code, and we were able to do Gauss-Siedel.